Okay, so let's say that we have an observer that's moving at, let's make the observer moving at a third of the speed of light. And so here's our space-time diagram. So we have x and t, and let's say that there is an event. So there's an event, let's say there's an event at x equals 3 in some units, t equals 2. So it's something like 1, 2, 3, and then t equals 2, something like that. And so our event, let's call it event A, occurs in space-time at x equals 3, t equals 2, and we want to know what x bar equals and what t bar equals. So of course it's the Lorentz transformations that gives us these values, and just to make the axes, let's tilt this, I say that much, that's the x bar axis. Sorry, let me just close the window real quick. Okay, that's the x bar axis, and so we'll just worry about the first quadrant here, and this should be the same angle with respect to that, so it's something like that. That's the t bar axis, and we want to know what these coordinates are. So they are, right, I want to get t bar on the space-time diagram means going parallel to the x bar diagram, x bar axis. So I'm going to move like that, and I'll get my t bar right there. And if I move parallel to the t bar axis, I can end up getting the x bar value, which is right there. So that's what I'm looking for, and the Lorentz transformations will give me these values. So let's see, we derived the Lorentz transformations. We have x bar is equal to 1 over 1 minus v squared square root times x minus vt, and that is 1 over 1 minus, this is really in terms of the speed of light, so that's 1/3, so that becomes 1/3 squared. I would take the square root of all of that. And then we have times the x value, which we said is 3, minus v, times the t value. Well, v is 1/3 in terms of the speed of light, so that's 1/3 times t, which is 2. So that's 2. And so what do we get here? We have 1/9 here. We have 9/9 minus 1/9. That's 8/9. So let me take the square root of that. So we get 3 over the square root of 8. And here we have 3 minus 2/3. What's that? Well, the common denominator is 3, so this becomes 9 minus 2 over 3. That's 7 over 3, and that gives us 7 over the square root of 8. And that's 7 over, all right, we can divide this into 4 times 2, and so we get 2 square root of 2, so 7 divided by 2 is 3.5, divided by the square root of 2. This number, which is x bar, is clearly less than x, because it's less than 3. Let's get t bar. So t bar is 1 over 1 minus v squared times t minus v times x, right? There's some symmetry here. These things look almost identical. We're just sort of flipping space and time. this gives us this term, which we already know to be 3 over the square root of 8. And here we get t is 2 minus a third times x, which is 3, so that's 3 over 3. And so that's 1, so that's just 3 over the square root of 8. And that is, right, again, it's 3 over 2 times square root of 2. So that's 1.5 divided by the square root of 2. That's a little bit greater than 1, so it's also less than 2. And so we can see that we have x bar less than x and t bar less than t.